Hello friends, welcome to my channel. Let's have a look at a daily challenge problem, problem 91, Decode Ways. In this video, we're going to share different formats of solutions based on dynamic programming. So here our purpose is practice. So first, I'll read through the statement of the problem to digest the requirement, and then we do some analysis, and finally we share the codes. First, let's look at the statement. A message containing letters from A to Z can be encoded into numbers using the following mapping. So we map A to be 1 and map Z to be 26. So to decode an encoded message, all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. Here is an example. So this number has two different ways of decoding. Depends because here we have 0, so we must include it with 1. So we have 1, 0, so that's 10. So then we have a 6. So the previous two digits, 1, 1, we can interpret it as two ones or as a 11. So that's the two different decodings. So given a string S containing only digits, return the number of different ways to decode it. So the test cases are generated so that the answer fits in a 32-bit integer. So here are several examples. So example 3 is special because this string starts with a leading 0, so there's no way to decode, so the output is 0. So in example 1, so there are two ways to decode. So we can regard it as 1 and 2 or as 12. So in the second example, there are three ways. So we can regard it as 2 to 6, or 22 and 6, or 2 and 26. So these are the three examples. So now let's look at the additional constraints or assumptions. So the first constraint is on the length of S, so which is not empty, and this is bounded below by 1 and bounded above by 100. Secondly, S contains only digits and may contain leading zeros. So these are the constraints. So with that said, so let's look at the methods. So here we're going to present several solutions based on dynamic programming. So here we're going to write several different formats as below. So we're going to use tabulation. So we are going to provide two formats. So we can use list or dictionary for retrieving the information. And also we are going to use memoization. So also we provide two formats, essentially one. So we are going to write hyperfunction by checking the number of different decodings for S from the index onwards or ending at the index. So we are going to analyze the first format in full details, and then we are going to present other formats directly or quickly. So let's first look at the DP solution for format 1. So here I'm going to initialize a DP table, and then we are going to interpret this DPI to be the number of distinct decodings for substring S and ending at index I. So we write as colon up to I plus 1, right? So in other words, from beginning and ending at index I. So this is the number of ways, right? Then we can assume the length of S is M. So here we are going to specify the procedure so that we can have a better understanding about the details. So this will be a three-step procedure. So first, we are going to treat an edge case. That is, if N is 1. So in this case, so there is one way of encoding a decoding or 0. So it depends on if X is a 0 string or not. 0 means this one. If it's not 0, so it's a valid, we have one valid decoding. Otherwise, there's no valid decoding. So this is step 1. So next, we're going to consider the case when N is strictly larger than 1. So step 2 is DP initialization and the set for DP0 and DP1. So this is our initialization. So we are going to have a length n DP table with all elements being 0 at the very beginning. Then dp0 is very easy to set. So if s0 does not equal to the 0 character, and then so it has one way of decoding. So we have dp0 is 1. Otherwise, it remains 0. So this is for the set for dp0. So for dp1, actually, we're going to consider two cases. First, if s1 is not 0. So in this case, at least, so we can interpret the second character, or s1, as one digit number. So we are going to increment dp by dp0, right? So this means that so each if we regard the s1 as a single digit character, so then if dp0 is 1, so then it yields 1 decoding for this 2 digit, so or length 2 string. So dp1 will increment by 1 if we interpret the 2 digit as from index 0 to index 1. So if this number as integer is between 10 and 26, in other words, it's a valid encoding. So we're going to increment by 1 of dp1. So this actually we use s0 up to index 1 as a 2-digit number. So this is the setting for dp0 and dp1. So next is a general rule for dp update. So this is step 3. So we're going to set the general element dpi for I, which is no less than 2. So in this case, first we're going to check if we can interpret si as a single digit number. So in other words, check if it's not 0. So if it's not 0, so each of the decodings ending at index I-1 corresponding to an encoding at ending at index I. So we increment dpi by the amount of dp I-1. So this is the first case. So next we're going to check if we can use si-1 and si as a 2-digit number. So in other words, we check this integer, right, to see if it's between 10 and 26. If so, then each of the different decodings ending at index I-2 corresponding to or yield a valid decoding ending at index I. So we increment the dpi by this amount, dp I-2. So here is the full 3 steps. So here let's look at one example, that is example 2. So if s is 2 to 6, then the final state of the dp will be 1 to 3. So in this case, we are going to return 3. So actually, the 3 decodings can be specified, given here. So this is one format of solution. Let's first write this format of solution, and then we quickly look at the other formats of solutions. For this purpose, let me first make some annotation. So this is a dp solution, right? So here what we are going to interpret is that, so this is the number of decodings for s ending at index I. Sorry, right? This is for this substring. In other words, ending at index I. So in this case, we are going to return. So we return dp length s -1, right? So this is the overall structure. So now let's translate this this 3-step into code. So this is actually very routine. So first, I'm going to introduce n. So that is length of s. So the edge case is if n equals 1. So we are going to return integer. So we are going to check if s0 or s itself does not equal to the 0 character. If this is the case, we are going to return 0. If this condition holds, we're going to return 1, otherwise return 0. And then the generic case, so dp initialization, right? First, we're going to have this 0 times m. Then let's first set dp0 and dp1. So dp0 is very easy to set. So if s0 does not equal to 0 character, so we're going to set dp0 to be 1. Otherwise, we just keep it 0. So this is one case. So now let's check for s1. So if s1 does not equal to 0, in other words, s1 can be used as a single-digit valid number. So in this case, so we're going to increment dp1 by this number, right? Another case is that we check if the two characters s0 and s1 can be regarded as a valid two-digit number. So in other words, we check if this number integer s0 to 2. So actually we can omit the 0 part. So if this is a valid encoding. If so, we're going to increment dp1 by 1. So in this case, we are going to use these 2 digits as a valid encoding. So this is the dp initialization and set for dp0 and dp1. So now let's look at the dp update. So for this case, we are going to iterate for I in range, so 2 to m, right? Because we have already set 1, 0, and 1. So in this case, first let's check if we can use si as a one-digit number. In other words, so this is not 0. If this is the case, so we're going to increment this dpi by that of dpi minus 1. And again, so we're going to check if si minus 1 and s ending at, so in other words, the character at index I minus 1 and the character at index I. So if we interpret this as integer, so we're going to check if it's between 0 and 26. So if this is the case, so we can interpret this piece as a two-digit encoding. Then actually we are going to increment dp by those of dpi minus 2. So this is actually the dp update. So finally, we are going to return dp n minus 1, right, or dp negative 1. So they're the same. So that's actually a full solution to this problem. So now let's do a special case check. Yeah, it passes example 2. Now let's look at the generic case. Yeah, it passes all the generic cases. So with this done, so we finished the first version of the solutions. So first, let me copy this function signature, and then we change this one to be v1. So now let's write another format. So in this format, we're going to still use the tabulation. So we are going to initialize a dp table, but we use slightly different interpretation. In other words, we look at the tail. So in this case, the dpi will be the number of different decodings for string starting from index I and up to the end. So we finally return dp0. So here actually we could use a dictionary to do the recording. Actually same as in the first format, we can also use dictionary. So this is not there's actually just some format. So here actually we can do the reverse scan. So this is our procedures. So still 3 procedures. First, I'm going to have initialize dp, so with length s, so we're going to have 1. So this is just for the help. So and then we're going to iterate I from index n minus 1 up to index 0. So we're going to check if si is 0 or not. So if we have a leading 0, then the decodings for the string starting from index I would be the number of different encodings will be 0. So in this case, we're going to set dpi to be 0. So in the other case, we're going to consider the case that si is not 0. Then we're going to update dpi. So there are 2 cases. First, we can consider to use SI as a one-digit number. So in this case, so we're going to set DPI first by DPI plus 1. So in other words, each of the decoding starting from index I plus 1 yields a decoding starting from index I. And next, we're going to check if we can use SI and SI plus 1 as a two-digit number. And if this is possible, we are going to increment DPI by DPI plus 1. So in other words, every decoding starting from index I plus 2 corresponding to a valid decoding starting from index I. So this condition is that if I plus 1 is inbound and this two digit forms a valid encoding number, in other words, between 10 and 26. So we're going to use this update rule. And finally, we return DP not, right? So this is the second format. So basically, we use slightly different interpretation of the DP table. So let's write this solution. So for this, let me use DP. So it's a dictionary. So I'm going to first let's see. It's a bit better to introduce an n, but it's not necessary. But let's do this, and then n will make it 1, and then we do the reverse scan. So for I in range n minus 1, -1 to 1. So this is the end, because the end is not included. So we are starting ending at index 0. So this is the increment step, -1. In other words, decrement by 1. So with that said, let's check if SI is 0. So if this is the case, so we're going to set DPI to be 0 because we have a leading 0. And otherwise, so first we are going to set DPI to be DPI plus 1. The reason is that each of the decoding starting from index I plus 1 yields a valid decoding starting from index I. Next, we're going to check if we can interpret SI and SI plus 1 as a valid two-digit encoding. So in other words, we're going to check if I plus 1 is inbound and as an integer, so SI up to I plus 2. So it's between 10 and 26. If this is the case, so we're going to increment this DPI by DPI plus 2. So actually, if I is out of bound, for example, in this case, so we're going to use a 1. That's why, DP we initialize as this. So n is out of bound by 1, right? So with that said, so we finished the DP update. So then we're going to return DP0. So this second format of solution looks shorter than the first one, because in the first one we write in a very detailed fashion. So with that said, let's look at the test case. So first let's test a special case. Yeah. Now let's test the generic case. Yeah, it passes all the cases. So with that done, so that's the second format of solutions. Let me copy this function signature and change this to be a v2. So now let's look at the other formats of solutions by using memoization. So here in the memoization, so we're going to implement a hyperfunction which computes how many different decodings, for example, for S starting from index and up to the end, or so ending at index from the very beginning. So this corresponds to the two formats of memoization solution. So let's first look at format 3, right? So here I'm going to write a function called decode idx, which computes the number of different decodings for this substring. So what we're going to return is decode 0. So in the second case, so we're going to compute the number of decodings for S ending at index idx. Therefore, we're going to return decode length -1. So let's first look at method 3 or format 3. So in this case, so we're going to this is a memoization, or we can regard we use cache. First, for this, I'm going to initialize a dictionary. So, and then we are going to define a decode function, so which accepts a index as argument. So here, this function in this format is going to return the different number of encodings for s starting from index up to the end. So what we're going to return is decode 0, right? So this is actually very routine. So if we have observed the two formats of solution using DP tables. So here, let's first check if IDX is auto bound. So we're going to return 1. And the other case, if IDX in memo in this dictionary, so we're going to return memo IDX. So this is another return condition. Otherwise, so we're going to check, you can follow this V2. So if s IDX equals this 0 character, and then in this case, we're going to set this to be 0. So you can make a comparison here. And then we're going to return 0 in this case. Next, we're going to consider this part. So here, let's first write as use as 1 digit, and equals let's introduce 2 variable use as 2 digit. So we're going to set them. So let's see, use as 1 digit. So we're going to use decode IDX plus 1. So first, I'm going to set use as 2 digit to be 0. So just to introduce this variable. Then what we're going to do is we check if IDX plus 1 is inbound, and if as a number with this 2 index s IDX, so ending at IDX plus 1. So in other words, we write up at 2 here is less than or equal to 26. If this is the case, so use as 2 digit will be decode IDX plus 2, right? So that's the two variable use as 1 digit and use as 2 digits. So now what we are going to do is that we set memo IDX to be the sum of these two variable, that is use as 1 digit plus use as 2 digit. And after we do this reset, we can return memo IDX. So that's the hyperfunction. So next, what we are going to do is to call this function. First, let's see, I'll call n equals length of the string s. Then we're going to return decode 0. So here we introduce this n because here when we call this decode function, actually in the function we use this n. So actually we can write using slightly different formats. For example, we can write length s here. But let's keep this form and do a special case check first. So let's do this. Yeah, it passes example 2, I guess. Now let's do like a generic case. Yeah, it passes all the cases. So with that said, so this is the third format of solutions. So now let's look at the fourth format. So I'm going to change this one to be V3. So I'm going to make a slight variance of method 3 or format 3. So here, what we're going to do is that we write a decode function, but we compute different number of the number of different decodings for s starting from the beginning and ending at that index IDX. So here, let's see. memoization, the second way, the second format. So here, what we are going to do is actually similar, right? So first, I'm going to introduce a dictionary, and then we write the function called decode, so idx. But here, the interpretation is different. So we're going to return the different decodings for s, starting from the beginning and ending at index idx. In other words, we write idx plus 1 here. So this is actually in parallel in some sense to the to the last solution. So what we're going to do is first, if idx is less than 0, then in this case we're going to return 1. And then if idx equals 0, right? So in this case, so we're going to set this one. So memo idx. So we're going to set it to be 1 or 0 according to if s idx is not the 0 character or yes. So if it's not, it's a valid one. So we're going to set it to be 1, otherwise 0. So then we're going to return memo idx. So this is the one case. Another case is if idx in memoization. So in this case, we just return memo idx. So now let's look at the general logic. So for this, I'm going to use as one digit to be 0, set to be 0, and use as 2 digits. It's also originally 0. So now let's see, if s idx is not 0. In other words, we can use s idx as a single digit encoding. So in this case, so we are going to update this one as 1 digit. So we update it by decode. So we are going to use idx minus 1 here. We look at the left. So due to the definition of all the row here. So now let's look at another case. So to check if we can use s idx and s idx minus 1 as a 2-digit encoding. So this is to check if idx minus 1 is greater than or equal to 0, and so as integer, if this s idx minus 1 and ending at idx. So in other words, we write idx plus 1 here. So if it's less than or equal to 26, if this is the case, so we're going to update use as 2-digit. So by the decode of idx minus 2, right? Then our memoization, so memo idx will be the sum of these two variables. So this will be used as 1 digit plus used as 2 digits. And then after this set, so we're going to return memo idx. So that's the hyperfunction for in this case. So now what we're going to do is to call this function, right? So for this, I'm going to return. So because here we didn't explicitly use the n, so we're going to call decode. We're going to call length s minus 1. So this is the format here. So with that done, so let's do a special case check first. Yeah, it passes example 2, I guess. So now let's look at the generic case. Yeah, it passes all the cases. So with that done, I guess that's about it for this problem. So here in this video, we presented 4 different formats of solutions based on the idea of dynamic programming as practices. So here the first 2 formats we are using DP table, and in the last 2 formats we are using memoization. So with that said, I guess that's about it for this video. Thank you.